Alrighty, so I've rebooted Windows 10, and I did sneak a peek. I'll just show you that to you. Let me move this over a little bit. I did sneak a peek to go at the server after I rebooted Windows 10. I snuck a peek over here at the server and went and looked at to see if the reservations went active. And you know, in the earlier video, the one before this one, I came here and I was looking for this. Actually, let me use my pen. I was looking for the for it to say, you know, reservation, and it would say inactive. That's what it says. If I had hit the F5 key, it would have showed up. In the last video I was here and I was saying, hey, I don't see it, but we'll keep moving on. Well, if I had hit the F5 key, it would have showed up. So it did show up, and it is showing as active. But active is great. I mean, that means that the client picked up its reservations. That's great. But what you'll see prior to the client picking up the reservation is it'll just say reservation inactive. Okay, so that's a good sign. And let's go look at our IPv4 pool, and same thing here. Before the client picks it up, it just says reservation inactive. Okay, so we'll go over to Windows 10. And no, it's not Windows 10, it's the server again. Here's Windows 10. Let's go full screen with it. We won't need an elevated prompt if everything's okay. So I just open a prompt here, and let's just do an ipconfig all. Okay, what do we got here? All right, so what we're looking for is we're looking for those reserved addresses, and you know, there's nothing about this ipconfig all that tells us that it was a reserved address. It doesn't. It's just the address given out needs to match what we reserved, and so we look for that here. Okay, so there it is for IP version 4. And there it is for IP version 6. Okay, then everything else is the same. And I just want to emphasize that on the server side, it absolutely tells us that a reservation was created and is active. But on the client side, it doesn't. It just shows us the values given, and it just happens to be that they're predetermined through the reservation. So that's up to us to know. There's like, this preferred doesn't mean it's a reservation or anything like that. There's nothing here that tells us it was a reserved address. So we did it. We're good. We're good. DHCP reservation for IPv4, IPv6. One other thing, as we move into the second year, they had some trouble with this, and I'm just taking a moment here because I've only burned up 3.5 minutes of the video. What they had was they have a router, so they had their DHCP server over here. DHCP. They had the DHCP server separated by a router. So we've got DHCP, and then we had a router here, and then over here was a Windows 10 client. Okay, so in other words, the Windows 10 client and the DHCP server were separated by a router. Now, DHCP requests are done through broadcasts. And routers don't pass broadcasts. So what happens is that the Windows 10 machine broadcasts, and there's the broadcast goes up to the router and then quits. And so the Windows 10 client never was able to, well, first of all, the server over here was never able to hear the broadcast because the router blocked it, and therefore it was never able to respond. So what you have to do is you install a relay agent. That's it. And very common for a router to have the option to enable a relay agent. Pretty much any router can be a relay agent. So what the relay agent does is it listens on one interface, or it can listen on both interfaces. It doesn't matter, however you configure it. So the relay agent listens for the broadcast, and then the relay agent, once it hears those broadcasts, will forward them to the DHCP server. And then the DHCP server now receives it not as a broadcast but as a unicast from the relay agent, will then respond with a lease package, send that back to the relay agent, which then responds by broadcasting it back out. So there are relay agents for both IPv4 and IPv6, and because if you think about it, you've got a routed network, you've got routers. We're going to have a lot more routers than we're going to have DHCP servers for most organizations, and so you've got like typically 2 DHCP servers. You can cover like hundreds of users with 2 DHCP servers. And the reason we have 2 is because if one goes down, right? DHCP is not a heavy role. The servers don't work very hard, but they are important. They're critical to our business. So you've got 2 of them for fault tolerance, but they can handle, hundreds of clients. So what you wind up doing then is you've got this distributed routed network, and then throughout your organization you've got relay agents that then forward these broadcast packets that are coming from out these networks that are distant. They forward those broadcasts to the DHCP server, who then responds with a lease offering. That's very typical. That is the typical deployment for DHCP is DHCP fault tolerant, and then relay agents distributed as necessary throughout your organization to contact your fault tolerant DHCP servers. Well, that's it. No need to go further. Again, just a learning opportunity, hands-on opportunity here. So we'll wrap this up, and I think that's it for our project. And of course, we always look for questions or comments from you as we move forward. So let me close this video, and we'll call it good.